Hi everybody, in this video we're going to obviously keep talking about decimals, but before we actually get into operations, I do want to spend some time talking about how you can go back and forth between decimals and fractions, and then also how we can order and compare decimals to each other or decimals to fractions as well. So that's what I want to do in this video. So we're going to talk mainly about converting between decimals and fractions. And then also we're going to do a little bit with ordering decimals as well. So how to tell which decimals are bigger than others, for instance. Obviously, some of them are pretty obvious, right? If one part has a whole number that starts with 1 and the other one has a whole number that starts with 5, then those you can figure out pretty easily. But some of our decimals can get a bit tricky trying to figure out which ones are bigger than others. So we'll talk about that in this video too. So the first thing I want to do is I want to go from decimals to fractions. And the easiest way to do this is to actually use your place values and to read the decimal correctly. All right, so let me show you with an example, and that'll make it a little bit easier, I think. All right, so here I have 5.6. So the correct way to read this would be 5 and 6/10. So this 6 is in the tenths position. And again, this is another lecture where if you need your place value chart, like we had in the last lecture, take it back out. Again, put that on a note card or do something so that you have it easily accessible with you. So the first spot after the decimal place is the tenths position. So we are in the tenths position here. Now, also remember when we talked about our place value chart from before, tenths has the number 10, but it's in the denominator, right? Or the hundredths position has the 100, but it's in the denominator. So to write this in a fraction is actually pretty quick once you can classify that place value. So the 5 stays the same. The 5 is still your whole number. And then the 6 goes over 10, right? Because that's what it means to be 10th. And that's basically it. Now we're going to still simplify. So we do have a fraction here that can be simplified, right? I can divide these each by 2. And I'll have 5 and 3/5 as my final answer. Okay. So the whole number just stays, right? Whole number stays. And then it's just that position, that place value that you need to transfer over. So let's try another example. So negative 10.05. Again, let's read it correctly. Negative 10 and 5. And if you look at your place value chart, this is in the hundredths position. So that negative 10 is going to stay here. Now I know I have a 0 here, but it doesn't matter. It's just still the number 5, right? 05 and just 5 are the same. So 5 over the hundredths position. Now we can simplify these both by 5. So I have negative 10 and 1 over 20. Okay, and let's do, how about one more? .57. Again, you're identifying that last place value because that's how we would read it. So we would read this as, I don't need to read the whole number here as 0. I can just leave it off and read it as 57 and this is in the hundredths position. So if there's no whole number, we don't need a whole number out front, so we're not going to have a mixed number. We'll just have a proper fraction. And I have 57 over 100. Now 57 over 100, let's see here. Can we simplify that any further? So if I think about factoring this, I cannot divide them both by 2, right? Because 57 is not even. 57 is divisible by 3. So let's see what happens there. I get 19. Well, 3 and 19 are both prime, and those don't go into 100. So this is going to be as simplified as it gets. And that's how we can convert over into decimals to fractions. So again, just kind of remember, here's your decimal spot. The first position is your tenths. The next position is your hundredths. And then the next position is your thousandths. I'll go up one more. Next one would be your 10 thousandths. 10 thousandths, and so on. So you have your full place value chart that you can reference here, but just kind of memorizing the first few place values is going to be really helpful to you, so that you have those ready to go. Okay. All right, so now I'm going to go the other way. This way's a little bit more work. So this time we're going to go from a fraction to a decimal. So there's a few different ways that you can do it here. So I'm going to just show you 2 different strategies. So strategy 1 is to try to get a denominator that is 10, 100, 1,000, etc. So some sort of power of 10, because then what happens is we can use the place value chart to transfer it to a decimal. So for example, let's say I have something like 1/4. Now this may be a decimal equivalent that you already have memorized. It's one that we use pretty often, but let's say you don't. So what we, actually, let's do 1/4. So I want to see, can I get this easily, so easily changing over using equivalent fractions to a 10, 100, or 1,000, or something higher. But usually those 3 are the ones we tend to stick with. So I can't really do an easy thing to 10, but I know I can do 1 to 100, because 4 times 25 is 100, and then 1 times 25 is 25. So now we can read this as 25 hundredths. So using our place value chart, remember the hundredths is 2 positions out, right? So I'm going to put the 25 like this. Okay. Let's do another example. So maybe I have something that's already in that form. Maybe I have 7 over 10. So it's already in a decimal or in a fraction that has a base of 10. Well, we can just read this, right? I would read this as 7 tenths. Well, the tenths position is 1 spot out, so I just put the 7 there. Or maybe I have something like -3 and 1/2. And again, 1/2 may be one of those decimals that you just already have memorized, which is fine. It's easy to convert over. But if you don't, that's okay too. So I'm going to take that 1/2, and I know I can get it to a denominator of 10 pretty easily. So I can multiply that by 5. So 1/2 is the same thing as 5 tenths. So again, we read this as 5 tenths. So our tenths position, again, is 1 spot out. So I just put a 5 in the tenths position. Now, what happens for your whole number here, so I don't just have a 0, because I have a whole number, instead of putting a 0 there, I'm going to put that whole number right here. So my answer then is going to be negative 3.5, which is also read as negative 3 5/10. Okay, so that's an easy way that you can get fractions to decimals, if you can get the denominator as something as 10, 100, 1,000, because you can use place values. But that doesn't always work. So sometimes it's very difficult to do that, or impossible. So if I had something like 1/7, how do I get 7 to 10 or 7 to 100? It just doesn't work. So we need a second strategy. So, sorry, this should say divide. So your second strategy, and this always works, so just as a side note, is that we can just use division. Now, usually it takes longer, so I will warn, if you can find an easy way to change over using the base of a power of 10, it tends to be faster, but it doesn't always work. So what we can do is we can go ahead and divide. So let me do one of the examples that did work. Start 1/4. So this is 1 divided by 4. So what we're going to do here is we're going to go ahead and set this up. Now, what's going to go on in this case here is I can't actually do 4 into 1. It doesn't make sense, right? So what we do is we add a decimal point, and we can always attach our zeros. And you can attach however many you need. I'm just going to put 2 on there to start. And now I start dividing. Now, when I go ahead and divide, I'm going to move that decimal point straight up. And then 4 does not go into 1, but 4 goes into 10. So remember, now you're thinking about this as 10. So 4 goes into 10 2 times, which is 8. Once you move that decimal up, you're just ignoring it. Forget that it's even there. Just think of this as 10 minus 8, which is 2. Bring down the 0, and 4 goes into 25 times. And now you can see there's my answer, 0.25 or 25 hundredths. Let's do another one. Right, so I'm just going to do the ones that I've already done just to kind of show you those for now. So this is going to be 7 divided by 10. So the 10 goes on the outside and the 7 goes on the inside. And then what you can do is you can put that decimal point afterwards, and then go ahead and attach as many zeros as you think you're going to need. Now 10 does not go into 7, but it goes into 70 7 times. And that comes out even, so I actually don't even need to add that extra 0 on. And I can see that my value is 0.7 or 7/10. Now, for mixed numbers, you can do a couple of different things. You can just work with the 1/2 if you want to, and then just remember to stick that -3 on at the end. That works. Or sometimes it's actually a little bit easier to convert to an improper fraction first. That's usually how I like to do it. So 3 times 2 is 6 plus 1 is 7. So we're looking at -7/2. And don't worry about the negative. The negative we're just going to tack on at the end. So we're going to do 7 divided by 2. Now 2 goes into 7. That's going to come out 3 times, which is 6. And obviously we have a 1 here left over. So what we're going to do, we're not going to use our fractions this time. We're going to use decimals. So I'm going to put a decimal point after the 7 to show where the whole number ends. And I'm going to go ahead and attach a 0. I can always attach zeros after the decimal point because they don't change the value. So 2 goes into 10. This is going to be 5 times, and it comes out nice and even. So you can see our answer is going to be negative then 3.5. Okay. If you don't want to convert to an improper fraction, that's okay too. What you could also do instead is to just do the 1/2. So I'm going to put a 0 here because 2 does not go into 1. I'm going to attach a 0. 2 goes into 10 5 times, which is even, so it's all done. So 1/2 is the same thing as 0.5, but then don't forget that my problem was actually negative 3 1/2. So it's going to be negative 3.5 instead. So you replace that 0 with that negative 3 if you have a mixed number. So whatever way you find easier, I tend to like the improper method better, but it doesn't matter. You're going to get the same answer either way. So let's do a couple more that don't come out so nice. So let's do 1/3. And again, this is not one that I can easily convert to 10 or 100. So I'm going to have to do some long division here. So I'm looking at 1 divided by 3. So that 3 goes on the outside and the 1 goes on the inside. And I can't do 3 into 1. It's not enough. So remember, we attach that decimal point, and then we put a 0 on there to create a value of, well, it's not a value, but it looks like a 10. So 3 does not go into 1, but it goes into 10. 3 times, which is 9. I subtract and get 1. Now I'm not done, so I'm going to attach another 0 and keep going. 3 goes into 10, also 3 times, which is 9. I subtract and get 1. Okay, I'm still not done, so let's attach another 0. Here I do 3 into 10 again, and I kind of see that it's going to just keep repeating over and over and over again. So if I notice that something's going to repeat, and I'm 100% sure of it, I'm going to stop. So we're not going to get an exact decimal here. We're going to get a fraction that's going to keep going on and on and on forever. So this is equal to 0.333. And what we can do is we write ... to show that it repeats. And the other way we do it is we also can write it like this and put a little bar on top. So whatever the bar is over, it means that it repeats. So this is saying that that 3 is going to repeat forever and never end. So sometimes we do get repeater decimals. A little side note, you just want to be careful of that bar. So let's say I wrote a value like this, 2.14, with the bar just over the 4. So that means 2.1, and then that 4 continues repeating forever. If I wrote it like this, with the bar over the 1 and the 4, well, that means the 1, 4 repeats forever, like this. Okay, so whatever that bar is over, that's what's going to keep repeating. It doesn't always have to be the first number. Sometimes it starts later in on a problem. Other times it doesn't have to be just one number. It could be 2 or 3 or even 5, etc. numbers that are repeating over and over in a pattern. So we use that bar to show that. All right, and let's do another example here. Okay, so again, that 7 is really tough to work with. We're not going to be able to get it into a denominator of 10 or 100 or 1,000 very easily without using decimals. So I'm going to use my division technique here. So I have an improper fraction. That's okay. I'm going to do 22 divided by 7. So 7 goes on the outside, and then I have 22. Now 7 goes into 22 3 times, right, which is 21. But I have a remainder, so I'm not going to write this as 1/7 like we've been doing with fractions. I'm going to attach a decimal and then attach a 0. Adding those extra zeros doesn't change the value. And I'm going to bring that decimal point straight up. 7 goes into 10 one time, which is 7. And I have 3. So again, I'm going to attach another 0. 7 goes into 30, let's see, 4 times, which is 28. So I subtract and I get 2. I'm still not done. I'm going to attach another 0. All right, 7 goes into 20. That's going to be 2 times, which is 14. And if I subtract here, I get 6. Still not done. I'm going to attach another 0. 7 goes into 60. Let's see, that's going to be 8 times, which is 56. And I get a 4. And you can see here that this is getting quite complicated, right? What we could do is we could keep going for longer to see if I do have a pattern there. It's a longer pattern, but there could be a pattern there. But if you've gone out 4 or 5 decimal places and it's still not ending and you haven't found the pattern just yet, then maybe it's okay to stop. So this could be a good example where we are going to end up rounding. Let's round this to the nearest, how about thousandth? So I'm going to stop here and I'm going to round instead. So if I'm rounding to the nearest thousandth, that would be this spot right here, 3 spots in. The 8 is big, so it's going to tell me to bump that 2 up. So I get about 3.143. This little squiggly here means about. It's not exact, and it's approximation. Okay. So sometimes we'll write it like this. Sometimes you'll see it as 2 squiggles like that, almost like an equal sign. Or other times you may see it like this or like this. There's so many different ways that we can write it, but they all mean approximately. I tend to just use 1 squiggle, but you may see it, the 2 squiggles tends to be very common as well. So we're approximately 3 and 143 thousandths here. Now, I will say one thing of caution just to be careful. Let's say you have a fraction that you're converting to a decimal and you have to round. You need to make sure you go out enough digits so that you have an extra one to help you round. So if you're rounding to the thousandth place, right, because that is 3 spots to the right of the decimal, then you need to make sure you have 4 decimal places, or else you're not going to be able to round appropriately, right? Because you always need 1 extra spot to the right to help you round. So just be careful if you're rounding problems here. A lot of times students will stop. They'll say, oh, round to the nearest thousandth, and then they'll just stop, and they'll leave their answer as 3.142. But that's not correct, because if I'm rounding, I need the next digit to tell me if that 2 stays 2 or if it goes up to 3. And here it goes up to 3. So just be careful here. When you're rounding, again, always go out 1 extra place so that you have that digit to help you round. Okay. So it's kind of nice. We kind of did some division here at the same time, getting through that piece as well. We are going to come back to division as well later on and do some longer decimal problems. So where we're not just dividing a whole number by a whole number and attaching, the decimal point in 0. So we'll do some other division problems in a couple of videos too. But if you're dividing a whole number by a whole number, we can easily just attach that decimal point and then zeros to help us continue our long division. Okay. So the last thing I want to do here is just do a little bit with comparing. Okay, so let's fix that. All right, so we're going to insert less than, greater than, or equal to make a true statement here. So let's do a fraction and a decimal to start. So let's say I have 4.56, so 4 and 56 hundredths, and then I also have 4 and 1/2. So the first thing you want to note here is that they need to be either both decimals or both fractions. We can't really compare 1 and 1. I mean, unless you're really good at doing mental math, but you need to be both in the same format. So you can do it either way. So I could make this a decimal. So if I do out my division here, we've seen the 1/2 before is already 0.5. So I can rewrite that as 0.5. And now I can compare 4.56 and 4.5. So how do I do that? If you're struggling to figure it out, then what you want to do is you want to line them up by the decimal point like it is here. And what you're going to do is anything that doesn't quite line up, you're going to use zeros here to help you fill in. And then you're going to go column by column. So here they're both the same. Here they're both the same, right? So same, same. But now here we have something different, right? I have a 6 and I have a 0. So the 6 is definitely bigger. So if that 6 is bigger, it means that 4.56 is also bigger overall. So 4.56, so 4 56 is bigger than 4.5. So 4.56 is bigger than 4.5 as well. Now you can also go the other way. Let's say you wanted to use both fractions here. You could do that too. So remember, we can convert this over. This is read as 56 hundredths. Now the only thing is you do want to make sure that you compare them as the same denominator. Now I know we can simplify this, but it's actually pretty easy to take that 1/2 and go to a denominator of 100. So it doesn't really matter when you're comparing as long as you have the same denominator. Okay, so this one is 56 out of 100. This one is 50 out of 100. So I can tell you right away 56 is more than 50. So again, this is bigger. So this is bigger. So this is bigger. And again, so you can convert one to a fraction or both to fractions or both to decimals. It doesn't matter. You're still going to get the correct answer. And again, hopefully you remember how to compare our fractions that we've already done. So once you have the same common denominator, and it doesn't have to be the least common denominator. Any common denominator will work here. So that's why I went with the 100, because it was pretty easy for me to convert that 1/2 over to. Then you just compare your numerators. 56 is more than 50, so that one is bigger. Okay, let's do maybe 1 or 2 more examples. Okay, so let's compare. How about, we'll do the same question. So 21 and 0.5618 and 20.9982. Now, this one is a little bit easier to compare because you can look at your whole numbers. The whole numbers are different. 21 is definitely bigger than 20. So when you have whole numbers, if you can see a difference right away, then that's easy. 21 is bigger, so this would be a greater than sign. If you can't see a difference right away, so now they're both the same, then again, what you want to do is you want to use that lining up trick that I've taught you before. So you line them up by the decimal point and you go column by column. So here they're the same, here they're the same, but in this column, they're different. So the 9 is bigger. So this is bigger overall. So once you have that first difference, whichever one is bigger, that's the bigger number overall. So this number is bigger. So I'm going to use a less than sign because this one is less than the other one. If one of my values is negative and the other value is positive, don't forget that negatives are always smaller than positive. So I don't even have to look at it. I can just put that in right away. My negative is going to be smaller than my positive. And that would be true too, even if I had mixed values. Let's say I had -1 1/4 and positive 2.6. I don't even have to convert over here because I know a negative is less than a positive. Now, if you have 2 negatives, you just want to be careful. So maybe I have -5.78 and -5.87. Now, this is where it gets a little tricky because they're both negative, right? So you can still line them up. I see that this is the same, but I do have a difference here. Okay. Now, your 8 is definitely bigger, right? So you want to be careful if they're both negative. And you want to be careful because remember, negative numbers are actually small, right? Negative number is smaller than positive number. So as you get more negative, they get smaller. So the 8 is bigger here, which is true. But because they're both negative, this means that this number is actually more negative, right? It's a more idea, but it's more negative. So if I think about my number line for a second, so here's -5, here's -6. Well, -5.87 would be like here, and -5.78 would be here, right? Because that's the 8 is bigger, so it's going towards that 6. But because it's more negative, this number actually now becomes smaller. Okay, so this is smaller, and this one is bigger. So it reverses if they're both negative. You just want to be careful there, because as your digits get bigger, it actually becomes smaller if they're both negative. So just watch out for that as you're comparing two negatives together with decimals. I think it really helps to draw that number line. So as you kind of start comparing them, once you find out the one that's bigger, remember that if they're both negative, the bigger digit is actually further to the left on the number line. So it makes the whole number smaller in this case. And that can be tricky. So you want to watch out for those when you're comparing digits.